Extend the Battenberg robotic measuring with the RobVirtual package. The RobVirtual package includes the RobModel Teach software, the digital twin of your Battenberg robotic measuring and tools, a 3D scanner, and calibration module on the robot arm. With the RobModel Teach software, you define all measuring points on the 3D model of your test objects and generate the desired robot pose for each measuring point. You use the robot poses when programming the test sequences in RobFlow. While you are creating your test sequences in RobFlow as usual, you can load the 3D model of your test object into the virtual robot cell and simulate the robot movements step by step. Check your RobFlow programming before you start the process on your real Battenberg robotic. Using 3D scanner technology, you can fit the 3D model of your test object with the scan of the real test object, and the 3D model of the calibration module with the scan of the calibration module on the robot arm. The RobVirtual package can be retrofitted to any Battenberg robotic measuring of the RobFlow 2.6 generation. You gain time and save precision because you define the robot poses directly on the 3D model of your test object. Your work will be saved by simulating your test sequences in advance, and you can transfer your test programs to Battenberg measurement robotic systems worldwide at any time, also along your supply chain. Let's take a look at the advantages of the Battenberg RobVirtual package using the example of testing an air conditioning control unit. To define the robot poses, the 3D model of the air conditioning unit is loaded into RobModel Teach. Now you can define as many measuring points as you want, i.e. robot poses, free on the surface of the model. You parameterize all spatial coordinates either freehand or enter the values. In snapping mode, robot poses can also be centered automatically. If the desired robot poses are based on the internal mechanics, then simply make the test object transparent in the geometric construction mode. Place support points on the geometric shapes such as circular paths and axes in order to construct robot poses from them. You can save all poses for further use in RobFlow. Battenberg provides you with your robotic measuring as a virtual system. Now load the 3D model and the generated robot poses. Position your test object anywhere in the virtual space. The virtual robot shows you the availability of all robot poses. Red balls symbolize an unreachable position. Green balls indicate that it can be reached. You can also select all robot poses individually and have them approached virtually. Now program your RobFlow test sequences as usual. Drag and drop containers with the desired actions and measurement tasks onto the surface. Connect and parameterize them. You can assign the individual robot poses to the actions. You can simulate your test sequence at any time during programming. With RobFlow 2.6 offline, you can also program and simulate in the home office or in parallel to the occupied measurement robotics. Now the test sequence is to be transferred to the real measurement robotics. The transfer process takes place in 9 steps. 1. Attach the calibration tool to the robot arm. The Battenberg reference tool can only be clearly attached to the robot arm. The rotationally and mirror symmetrical shapes are easy to fit and allow the exact position of the robot arm to be determined. Therefore, the reference body serves as the origin of the transformation chain. 2. Place your test object on the measuring table. 3. Set up the mobile scanner. 4. Connect RobFlow to the Halcon server. 5. Drag the calibration container under your starting position and start the calibration process. 6. The reference tool is scanned and fitted with the 3D model. 7. The test object is scanned and fitted with the 3D model. 8. The virtual and real coordinates are automatically synchronized in RobFlow. Now simulate the real test sequence. 9. After a successful simulation, start the test sequence on your Battenberg measurement robotics. The RobVirtual package offers you greater precision, more safety in handling the robot, and facilitates cooperation, regardless of whether the employees are in the home office, in different plants, or in different countries.